Hey everyone, today we'll be looking at amortized analysis and how it's being used. So before getting into the actual details on what it is, let's start with a simple example. Say you're a new college student, right? And you have this obsession to drink coffee every day. So you find a coffee shop in the nearest canteen, and what they do is that they charge you $5 for one cup, and then they charge you $1 for one coffee. So the catch in this shop is that you buy a cup, you can use it for 5 times, and then you have to throw it away. That is, the cup cannot handle coffee more than 5 times, and then you want to drink coffee every day. So essentially, if I buy one cup, I can use it to drink coffee 5 times. So it'll be 5 into 1 plus 1 into 5. So totally I'll be spending around $10 for drinking coffee for 5 days. Now imagine if you do the normal analysis that we have, that is worst case analysis. So in the worst case, how much money will you need to drink coffee? The worst case would be that you don't have a cup, so you have to buy a new cup, which is $5, and then you want to buy coffee as well for it, which is $1. So totally you'll be paying $6 every time. And the best case for this would be when you already have a cup, and then you're just going to buy coffee, so it will just be $1 for that day. So now we have these two cases. So based on that, you might think, if today is a very good day, I just need $1. If it's a very bad day, I'll be needing $6. But is this really the right way? Say if I'm a student, I don't want to take $6 in my bag every day, right, to drink a cup of coffee. So what do I do in that sense? So let's take a step back and then look at this a bit deeper, right? So assume since you're a new student, the first day you go, you get a free cup, right? So $5 is gone. So on day one, I will be spending just $1 for the coffee. On day two, this is my second use, it'll be $1 again. Day three is $1. Day four is $1. On day five, it's again $1. On day 6, something interesting happens. I've used my cup 5 times, so I need to buy a new cup now. So that will be 5. And I need to buy coffee for it as well, which will be 1. So this becomes $6 totally. And again, day 7 is 1, day 8 is 1, day 9 is 1, 10 is 1. And again, 11, the same logic applies, and we have $6 here. So now imagine if I do the worst case and I carry $6 every day, I'm gonna have so much more money in my bag that is not at all required, and it's not gonna be sufficient. If I use $1, that's the best case, I'll come to a problem on the 6th day or the 11th day. So how do we solve this? Imagine instead of taking $1 or $6, what if we just take $2 every day instead? So say I take 2 on the first day, I spend 1 for the coffee, I have 1 left. I take 2 on the second day, I again spend 1, I have 1 left, and same continues. So 2 here, I've saved 1, 2 here, I've saved 1, 2 here, I've saved 1. So by now, I've actually saved $5 totally from here to here, from day 1 to 5. On day 6, when I use my $2, I again use my $1 to buy the coffee, and I use the $5 that I've saved from the previous 5 days. And then the math works out. I again save $1 here, and I continue this, and I'm able to drink the coffee every day and pay for it like exactly without taking any extra money or any less money, right? So basically, if you see, if we were to do worst case analysis for this example, it is $6 that we see here, 6 here, 6 here. So we'll have to carry $6 every day. But instead of doing the worst case, we do the amortized analysis, which from this example that we see means that you don't zone in into a single operation. Instead, what you do is you sort of write out the entire sequence of operations that you're going to perform. So that is from my first day in the college buying coffee till whatever day I decide, and then I map out all the operations I will be performing on those days, and accordingly I analyze on what I actually need. So this cost, as we've seen in the above example, will be just $2. So essentially what this says is that you don't have to always zone in into the worst case. Like there are many cases or algorithms in real life where the worst case is a very rare occurrence or a very infrequent occurrence, in that we don't need to be so pessimistic towards it, and we should consider a sort of more average basis, and that is where amortized analysis comes into picture.